Today we are going to be making a command line project that I have called Harebrew, and you see it's a command line utility to bootstrap Hare files and projects. I'll leave a link to my Sourcehut in the description. Go ahead and grab this, and you might also be interested in the Hare tutorial because inside of here, in the getopt directory, I have a number of example programs to show you how to use the getopt module, and we will also briefly cover these. And also, if you click on my profile, here's my email address, and if you need help, go ahead and email me. And now, I would like to say a brief disclaimer. I am not a professional programmer. I'm still learning. So this is a bit of a learning experience for me. There's two books I'm currently working through. It's this one, Linux System Programming, 2nd edition by Robert Love. And I can really recommend this book. You see, it's 2013, but it's not outdated. And it has 24 5-star reviews. This is really good. We're going to reference this. So let me go ahead and pull this up. And another book that I'm working through is this one right here, Advanced C and C++ Compiling. This goes through binary files, linking and loading, the whole compilation process. And this, I can also really recommend this book. This is a really good one. So these are the two books that I'm working through right now. If you're more experienced than I am, you can probably find some better ways to do things within this project. Now, I have access to O'Reilly through my library. So go ahead and check your local library and see if you can get access to O'Reilly. They might have a program, because I have access to pretty much any programming book you can think of, right? Anything from Bjarne. There's a new book. There's a new Zig programming book that just came out. You see Systems Programming with Zig. Oh man, this AI overview is really annoying. I don't think there's a way to turn it off. It just eats up bandwidth and CPU. So you see, with O'Reilly, through my library, I have access to pretty much any programming book at my fingertips, right? They've got some books by Andrew Tannenbaum, which I don't know if they have his operating system book, but they have computer networks. And there's a really good book, this is a classic, I don't know if I'd say classic. It's a really good book, Computer Organization and Design, right, RISC V edition. I've worked through some of this as well. This is a really good book as well. So check your local library. You might have access to O'Reilly, and that's how I have access to it. So I've written a brief little agenda, I guess we could call it, for Harebrew. We're going to do we're going to get into Hare project structure and the initial build out, the getopt module for command line option parsing, the OS create function for file creation, as well as file permissions in UMask. We're going to be dealing with environment variables with OS get env, and then command execution with the OS exec module. So very briefly, here is the project. And let me give you a brief demonstration of how this works. So you would say Harebrew, and let me pass in the H flag, and you see these are all the different options. And so if we want to make a file, you say Harebrew F and then whatever file, and we'll just make main. And you see it appends the .ha extension and scaffolds it with some basic code in order to get you going. And then say, for example, So it's sourcing my editor. Now say, for example, someone doesn't have their editor set, and I run this again, it's going to put you in VI, right? Hello from Hare. And so you always want to have a fallback in order to in case someone doesn't have their editor environment variable set. And then what we can also do is you say Harebrew and then pass in the P flag for a project, and let's name it Tarantula. You can pass in an L flag for a license, but I'll leave that off. It defaults to GPL3. And then it creates a project. Let's cd into here. And you can see, since I didn't specify a license, it defaults to GPL3. And then you just have to input your one-liner and this information here. It creates the makefile to readme. Inside CMD is where you have this folder, which is it's named after your project. And then inside of here is your main. And then inside the docdir is where your man page goes. So here's the project right here. And if you copy this byte for byte, you are going to, it's GPL3, so you have to retain the same license. Here's the makefile, and we're going to go over this as well. If you don't have any previous experience with make, that's fine. I'll show you how to use it. It can be kind of intimidating at first, but it's just like anything. The more makefiles you write, the more comfortable that you get with it. Inside the docdir is where your man page goes. So we're going to be using a command line utility called scdoc in order to convert this into a man page. And it has its own syntax. And then what you do is you run it through scdoc, and it creates an actual Linux man page. And inside of CMD is where your main file is. And you see I have this broken down into modules. So we'll get into this. And now a just file, you probably have this in your repo. What just file is, it's just a command line runner. Okay, so it's very similar to a makefile. Okay, sorry, make tracks dependencies and things like that. So make is much more sophisticated. I use just files for projects because what you do is you just define a target, right? And then you have your recipe, like what it runs. Okay, so if I just say just main, instead of having to go through all of these folders to get to my main function, right? Instead of having to go through this folder to get to this file here, right? Or same thing with my manual page if I want to edit it. You know, you just say just and then your target, and this puts you right inside it puts me right inside my main file, right? Same thing with if I want to edit the man page, you just say just and then the target, and it runs the command that you have on that target. And I just have it set to execute on these files within the subdirectories. And so let's, okay, so I gave you a demonstration of the program. Let's go to, okay, I'm going to leave this open because we're going to grab we're going to be using a portion of this here. Let me go ahead and close this. And from the Hare page, the Hare main website, if you say project library, and then scroll all the way down to the very bottom section, utilities and system tools, all these are command line programs. So this will give you an idea of how they structure their projects, and things like that. Now, Haredo, sometimes you'll see Hare projects with a .do extension instead of a makefile, and that's this utility here. It's very similar to make, but it's for Hare projects normally. So if you see a .do file, that's this Haredo. And there's one or two of these that we're going to reference while we're building our command line utility. So from the main page, the main Hare page, say documentation, and then using Hare, and then project structure. And this will give you an overview of the project structure, right? Copying, README, and makefile often appear at the root of the project tree. And inside of CMD, then you have a subdirectory usually named after your project, and then the main file. So see CMD example, and then it's usually main.ha. And then inside the docdir is where your manual page is going to go. So let's go ahead and let's start building this out. So go ahead and create your directory, name it Harebrew, and let's cd into here. And we want to create a copying, this is your license, a readme.md, and a makefile. And for the moment, we are just going to put our main.ha at the root of the directory for now. We are going to refactor this though into an actual project structure along these lines here. And let me also make a docdir because this is where we are going to put the manual page. If I run man Harebrew, you can see here's the man page for it, and has all the proper sections, right? Name, synopsis, description, options, set your editor environment variable, here's a project structure, the different licenses you can use, examples, and then where to get the source code. And so we're also going to be making a manual page for a project, and that's where it goes. It goes in the docdir. So let's go ahead and start prototyping out our main function, our main file. And in order to do so, let me bring up the getopt module documentation. And you see this is for command line option parsing, and it gives us some examples here. And again, you can reference those projects that are in the project library for how they do this, okay? And let's go ahead and very quickly, these are the files that I have. If you grab that Hare tutorial, these are the files that I have in order to show you how to use the getopt module for command line option parsing. So this is the most basic one, and getopt parse returns a command, which is right here. So it's getopt command, and it's a struct. And we're just listing, initially this is what's called within the documentation. Okay, this is a flag help, and then I'll show you an example of parameter help. And this first part here is your main command help, okay? And then I show you in these commented sections how these parse out, okay? And how you actually get at these. You see it gives us an example here. So you would usually call this CMD, and then once you define your arguments for parse, which this is a wrapper. You see parse and try parse for the main entry points. Parse is a wrapper around try parse. And then you would do something like this, a for each loop, and then switch on all your ops, which are these right here. These rune flags right here. And then this would be the string value, of this right here. So here's the string value. And so if you step through all of these, let's look at, okay, so here would be, this would be a help flag for, let me scroll back up here, here's flag help, okay, and then this right here is parameter help. And so this is an actual parameter, and it shows you how this parses out, depending on what you enter into the command line. Now, once you have just a flag like this, anything after it is going to be placed in args. And so depending on how you define this help message right here, depends on how, when you run your program and input your arguments, that depends on how it's parsed, okay? And then I also have another example that I've just named Harebrew, and these are subcommands, and it would just be another command help message, okay? That's what this is right here. And the way that this is parsed out is right here. I have it all commented to show you how this parses out. So this would be a subcommand, right, inside the CMD struct, and then you have your string, which is your subcommand, and then a pointer to another getopt command, which is this right here. It would be this right here. And I show you the way that this parses out. Now here's the pointer to the getopt command, right? Here's that command right here. So it would show you how this would parse out based on how you define your help message. And then I show you how to actually, right, get these values in order to use them in your program. So go ahead and grab that and step through those. So let's go ahead and start. What we want to start out with is just a file. Okay, so we'll say const cmd, and let's use getopt parse. And the first argument we want to pass in is osargs, because this is going to get the command line argument. Now here is your general command help. We're going to name this Harebrew, and the general command help is create a Hare file or project. And now this is going to be a tuple, and we want a rune. So this is our flag, and it's file, and then you say file, and then creates a .ha file. Okay, so that's what we have so far. And I'll show you how this is going to work. Right, so now we would defer getopt finish, and then pass in a reference to cmd, a pointer, a reference. I'm used to C++ references, so that's why I just call it a reference. Okay, now make sure that you use defer, because if you don't defer this, anything you do here, this is going to be invalid. So if you're running into some issues and something's not parsing properly, always start with the basics and make sure that you're deferring this to the end of the scope. And then you would say let opt in cmd ops, and then we're going to switch on this. Now of course this value here that we're naming opt, you can name this anything you want. You can name this I, and then you would switch on I.0, right? So this is just arbitrary, but you generally want to sort of stay with conventions. So we're going to say opt0, because what we're actually switching on is, so we have a cmd .ops, which is a command. Okay, so getopt parse, you see it returns a command, and you see it's a wrapper for try parse, and so it returns a command. And so let's look at that. Okay, as I showed you in some of the examples, this is what a command looks like, and this is what we're iterating through in our for each loop, you see this is a slice. So when we say for opt and cmd opts, this is what we're actually iterating through, is this array right here, the opts array. And now when we switch on the first value in the tuple, right, that's why we're saying opt.0, because it's a tuple, and which is right here. Okay, you can see, here's the tuple right here. This is what we're after, is this rune flag, okay? So what we would say is, goodness. Okay, so what we would say is case and then F, and then we want to do something here. Okay, this is where we're actually going to run the function that creates our file. So let's call it create file, and we're just prototyping this for the moment. And like I said, once we get deeper into this project, we're going to refactor this into an actual project structure. For the time being, though, let's just create this function in our main file. So create file, and void Okay, so I'm just prototyping out this function. And what we want it to take is a reference to our CMD. And because that's what we're actually going to we need these values inside of here in order to continue on with our program. And what we want to do, okay, so we have that, we're saying create file. Now a switch expression has to be exhaustive. So now we need a default case, and what we're going to do here is we're going to say, we're going to call this print usage function, because this is what's going to run if someone doesn't enter the correct flag. And so you see it takes a handle, which is usually standard error, is where you print this to. The name is a string, which you usually put your main program name, and then you see it takes a slice of a help message, which is the command help. Okay, if you remember from command, right here, this is what we're passing in as the final parameter. So let's call getopt print usage, and I think it returns an error. It does. It returns an IO error. So for the moment, let's just use the error assertion operator, and we're printing the standard error. The name of our program is Harebrew, and then we're passing in CMD help. And then let's call abort. And so this is what's going to run if someone doesn't enter the proper flag. Now here, what we want to do is, for the time being, let's just print out the name of the file that we pass in for the F flag. So let's call that file name. And the way we want to get this, it's CMD. So we're passing in, here we're passing in a pointer to a reference to this right here. And this is what holds, this is what parses all of our command lines. And again, it returns a command, and what we need now is this second tuple value. Okay, if I come back to command, so we're switching on the rune value, and when you say -f file and then pass in whatever name, that's going to be this string. So this is what we want to get now in order for the name of the file. And so it's the ops, you see it's ops. This is the ops field of the command struct, which we've named CMD. And then it's the first it's the first element of the slice, and then we want .1 because it's the second element of the tuple. And again, tuples start from 0. So here's the rune, here's the string. And this is going to give us the name of the file in order to operate on, in order to create this file and open it inside of our text editor. So let's say file name, and let me just kind of double check everything here, but I think we're pretty good to go to try and run this program. Okay, I think we are. So let me come back into the top level of our directory, and for the moment, okay, let's say Hare run main and pass in the H flag. Okay, I didn't import anything, so we need getopt, and we also need OS. And I think that's it for now, because we're using OSArgs here, and obviously getopt. Okay, so I think that should be good for now. Let's run that again. Okay, now you see how it created this for us. See, main.ha, and of course when we build this, this is going to be replaced with Harebrew. You see, creates a Hare file or project, and that's our main command help. This is the first string that we created in the parse function that we passed in as an argument as part of the help, as part of getopt help. And then it lists, you can see, we have main.ha, again, this will get replaced with Harebrew. You can pass in the help flag or the F option with a parameter. Okay, and you see, F file creates a .ha file. So, now let's run it with the F option and put in a file name, and it should print it with inside of our create file function. So let's say Hare run main, I'll pass in the F flag, and I'll say random file. And you see it prints random file. So we are indeed grabbing the correct part of the command struct in order to create this file. So let's go ahead and what I'm going to do is just make a simple makefile in order to build this program. You don't have to do this, but it's going to make building this much easier. And I'll say it has to be Hare build. Okay, that looks good. Yes, I think we're good. Okay, let me run make. Okay, so here's Harebrew, and let's pass in the H flag, and you see it runs just fine. And now let's pass in the F flag, and I'll say hello, and so it prints hello. So everything's running just fine. So now we need to actually come down here with inside of this function and start building this out. So you should never, I've taken a couple programming classes in college, and unless you're more experienced, you should never just immediately start writing code, right? You should always kind of prototype out your program and plan it in advance. So what we need to do is we need to create the file. I'll say create file, and what we need is OS create. So that's what we're going to use for that. And then what we want to do is, well, let's call this, what we want to do, we need, okay, so you know how when you open a file, when I showed you with Harebrew, it's already populated with the scaffolding code? Let's go ahead and define a variable for that. Let's call it, we'll call it main str. And this is what's actually going to be put inside of our main file when we run it with the F option. So it's basically a main function with the FMT module. Now, if you want to put more, if you want to pull in more modules or put more code in here, that's fine. You can do that. Let's put we'll say hello from Hare. Okay, and okay, that should be good. I might have to use a raw string here. We'll see. I might have to escape this. Let me escape this because I think I have to escape these quotes right here. Or in that case, I might use a raw string. We'll see. Raw strings are constructed with backticks in Hare, and because you can't have a main function that has nothing in it. And okay, so that's what's going to that's what's going to get written to our main file. So what we want to say is write main str to file, and then what we want to do is get editor environment variable, and then what we want to use is the OS exec to execute editor on file. And that's the basics of this function. It's not that complicated. And okay, we'll worry about the exec thing last. Okay, so first things first. What we need to do, we have the file name. So now let's go ahead and create it. And we'll say fd because this is a file descriptor. And we want to match on OS create. And let's go ahead and look up this function. So, okay, so you see creates a new file with the given mode. That would be right here. If it doesn't already exist, and opens it for writing, which is exactly what we need. Now it says only the permission bits of the mode are used. If other bits are set, they are discarded. And what that means is a file permission mode has, I think it's about 12 to 15 bits on it. And it can, the first couple of bits are determine if it's a file, a directory, things like that. So only the permission bits are used, and I'll show you what that means. And so let's go ahead and this is what we want. Now the path is a string to our file, so we'll pass in file name. And let's look at fs mode. And you see file mode information. These bits do not necessarily reflect the underlying operating system's mode representation, though they were chosen to be consistent with typical Unix file permissions. And all implementations shall support at least user read write dir and reg. Now what it means by all implementations, that means all implementations of Hare. So Hare is cross-platform and cross-architecture. So say you're running Hare on AArch64 OpenBSD, it's saying that these are supported at least. And now let's go ahead and look at that little section that I was talking about. Okay, and let's look at permissions of new files. This is inside of, as you can see, this is System Programming 2nd edition by Robert Love. And what this is, okay, see permissions of new files. The mode argument is the familiar Unix permission bit set, such as octal 0644. Technically speaking, POSIX says the exact values are implementation specific, allowing different Unix systems to lay out the permission bits however they desired. Every Unix system, however, has implemented the permission bits in the same way. Thus, while technically non-portable, specifying this or this will have the same effect on any system you are likely to come across. So what this is a special permission, and this has to do with set UID and set GID and the sticky bit. This is what we're mainly concerned with. So this is user, group, and other. And these are the permissions that are going to be given on the file when we create main.ha. This is what we need to set. Now you see it says, nonetheless, to compensate for the non-portability of bit positions in the mode, POSIX introduced the following set of constants that may be binary ORed together and supplied for the mode argument. And I'll show you exactly what that means in Hare. Now this is in C, obviously. This book is focused on C. And so what these flags are right here, see, owner has read permission. Okay, that's exactly what this right here is, right? User read permissions for the file owner. So these are the same. You see, mode is an enum, and it has a custom storage class specifier of uint because it's normally an int. And so these correspond to these modes in C. Okay, now you see the actual permission bits that hit the disk are determined by binary ANDing the mode argument with the complement of the user's file creation mask. It's called a umask. Now if we look and you, in your terminal, if you type in umask, it shows you what your umask is. And this is a typical classical umask is 0022. This is in octal format, and you do not want to change this. So do not change this unless you are an experienced programmer or a system admin. So the umask is a process-specific attribute that is usually set via the login shell, but is modifiable by the umask call, allowing the user to modify the permissions placed on newly created files and directories. The bits in the umask are turned off in the mode argument given to open. Okay, so what this means, so it's called a umask because it's a user mask. It's also called a bit mask. And so it says, thus the usual mask of 022 would cause a mode argument of 0666 to become 0644. And you see, so these bits right here are masking these bits. And so it's turning it into 644. As a system programmer, you normally do not take into consideration the umask when setting permissions. The umask exists to allow users to limit the permissions that their program set on new files. So you see, as an example, the following code opens the file given by file for writing. And you see this is exactly similar to, if we go back to the Hare documentation and look at, you see right here, so that's this right here. So you have the mode and the flag. The flag, this is a default argument, and it's opened in write-only mode if it doesn't exist, and it truncates it if the file does exist already. And so that's exactly what this is here. So here's the file, okay, which is a path. Here's the read-write and the creation flag and the truncation flag. And then here are the permissions that you see they're binary ORed together. That's what this means when it says they can be binary ORed together, okay, and supplied for the mode argument. So what that means is we can do the same thing in Hare. Okay, so you see it's created with the permission 644, even though the mode specifies 664. Okay, trading portability, in theory at least, for readability, we could have written the following to identical effect. And you see this is in octal format. This is typical Unix permission bit set. And it's exactly identical to this right here. Okay, so these flags, these mode arguments, these mode flags are being binary ORed together. Or we could pass it in octal format. So now let's come back over to our Hare program and look and see how we want to call create. So first we need a path, which is the file name. Okay, now what we could do, it's an octal format, so you need a leading 0 and then an O, right? Because this is binary, this is hexadecimal. So O, a 0, and then a lowercase o. Okay, this is a lowercase o. and then you would say 644. Now we do have a mask on it, so you could say 664, and it would still turn into 644. Okay, or it's saying, so we could pass it like that, or what we could do in Hare, okay, what you'd want to do, how you binary or these together, is you create a variable. So we'll make it const. Now, const is technically broken in Hare, but it's good to get in the practice of making something constant unless you know for a fact it's going to change. So we'll name it perm for permissions. Okay, and now you put this inside of a tagged union. Okay, and you binary or this together. And so let's look again at the modes that we want. Okay, we want user read write, and then we want group read and other read. Okay, and again, this is a mode inside of the FS module. So what that would look like is you would say FS mode user read write, and then you binary or this together. So the binary or, and then FS mode other is, oh sorry, this is group read, and then binary or FS mode other read. Okay, and that's exactly similar to passing in this right here. Okay, so you can do either one. For the purposes of simplicity, we are just going to use the octal format of the standard Unix bit permissions. So let me go ahead and delete this. But again, this is what it would look like if you wanted to create this just like this here. Okay, so either one is valid. Either one is valid in order to set the permission bits on the file when you create it. Okay, so let me go ahead and delete this, and let's come down here. So that's our function call. Again, the write-only and truncation flag, this is a default argument. You can see with the equal sign, and it's passing in these values. If you wanted to, say, open this in read and write mode, you would have to modify this and pass that in when you call the function. But for now, that's perfectly fine for our use case. And so on success, we'll say caselet handle IO file, because that's what this function returns, and we'll say yield handle. Now you can name this whatever you want, right? Inside of a caselet expression, inside of your match expression, this is just an arbitrary name, so this can be whatever you want. And then caselet error, and so it's FS error, I believe. Let me double check that. Okay, so it is an FS error. Now let's look at this real quick, IO file. So, and what I want to show you is, you see on Linux, file is a file descriptor. This is what it returns, and you see it can be used as a handle in most situations, okay? Because an IO file is, you can have an IO file or a stream, and I'm trying to remember where exactly that is in the standard library. Okay, let's not get too complicated. Okay, so it returns an IO file, which can be used as a handle, and on Linux, you saw it said it's a file descriptor. So that's why I'm naming this FD. Now, if we wanted to, we could say main FD, right? Whatever you need to name this in order to keep track of it. And so it returns an FS error on error. So let's handle this. Let's handle the error case. Okay, so now that's error handling on our file, and we're creating it. You see we're passing in file name here, and then with the permission bit set. So this is going to create our file, so check. Okay, so now we have this. This is good. Okay, let me say check. Okay, now what we want to do, now this is opened. Okay, if we go back up here, you see it opens it for writing. Now, in order to write or read from a file, in order to write to or read from a file, the file has to be open. So it opens it for writing. It opens it in write-only mode. See? So the file right now is open for writing. What we want to do is we want to defer IO close because we want to close this file. And we're calling it FD. So we pass in the file descriptor that is returned from OS create to IO close in order to close this file, and we're using the defer keyword to defer that to the end of the scope. Okay, so now what we want to do is write the string to our main file. And you see the string it's this string here. So this is what we're going to be writing to our main file. So when we create it, it's pre-populated with some basic scaffolding so that you don't have to type all of this in. And this is good for like making one-off programs, if you're just trying simple things out so that you don't have to, constantly type in export function main void equals, and it just bootstraps a file for us. Now, what we want to use in order to write that string to our file is the fprint function. And you see it takes a handle and type formatable, which is fmt formatable, which our string qualifies, and it writes it to an IO handle. So it can return size on success or IO error on error. So this is what we're going to use in order to write this string to our file. And I'm not going to capture the size return value, so let me just match on it, and it's fmt fprint. Okay, now what we want to do, we need the handle. Okay, so we need the handle that we're going to write to, and then the string that we want to write. So this is going to be FD. That's our handle. That's our file descriptor. Now remember, file name. This is the path in a string value. Okay, this is the file descriptor that you want to use to perform read and write operations on. So these are two separate things. Don't get these confused. File name is a string value, and that is simply just the name of the file. And what is returned from OS create is your file descriptor, and that's what you're going to use to perform read and write operations. And what we want to pass in is main str. So it's going to write this string, okay, to this file here that we have created with OS create. And you see we're passing in the file descriptor. And so caselet sc size, and I'm just going to say yield. I'm not going to use this value. I believe it's an IO error. Okay, so now we're writing our string to our main file. Check, that's finished. Okay. Now what we want to do is use osGetEnv in order to get the editor environment variable. And what we're going to do is put in a default value in case this returns void. So we're going to use the osGetEnv function. You see looks up an environment variable and returns its value or void if unset. So it takes a string value, which is the envar that we want to look up. It returns a string if it finds it, void if it doesn't. So what we want to say is let's name this editor, and let's go ahead and match. And what we want to say is osGetEnv, and we need editor. So in all caps usually, and so if it's void, caselet v void, and if it's void, if the editor is unset, we're going to yield vi. And what that's going to do is, if the editor is unset, it's going to open this file in VI, because any Unix system is almost guaranteed to have VI installed by default. And then so case-let s of type string yield str, yield s. And so what this means is if the editor is set, it's going to return it to our editor variable here. Okay, so now, okay, so check. So now what we need to do is, let me put this here, os exec, I think it's cmd, to execute editor on file. Okay, so now this is where we're actually going to be opening the file inside of our editor. Let's create a separate function for that. Exec editor. Okay, now in order to use this, okay, let's go ahead and look this up. And you see os exec is command execution and process management. Okay, os exec handles the execution of arbitrary commands, so we can run like shell commands, for example. And that's exactly what we're going to do. We're literally using this in order to run our editor on the file just like you would from the command line. Okay, and it gives you a brief synopsis of kind of how to do this. Okay, and if we look up, what we want is a CMD, and you see it prepares a command based on its name and list of arguments. The argument list should not start with the command name. It will be added for you. The argument list is borrowed from the strings you passed into this command. If name does not contain a directory separator, the path will be consulted to find a correct executable. If path resolution fails, no CMD is returned. And it gives you an example of exactly how this is used. And the example that it's using is it's executing the echo command, right, which is a bash command. And it's saying hello world. So if you were to run this, what this would do is it would just echo hello world out to the console. So let's grab this and copy this, and this goes inside of our exec editor. Inside of our exec editor, function. And right now what's happening is we're echoing hello world. Now what we need to do is we need to execute our editor on file name. So let's go ahead and fill in these parameters. We'll say editor of type string and file name of type string. Now, editor operates on a file name, right? From the command line, when you say, like if you say vim and then main.c, you know, you're operating on a file name. You're not operating on a file descriptor. Okay, so exec.cmd, it takes the file name, right, which is the string path, right, which is this right here. Okay, so it takes a string value of the name of the file. And I just realized what I forgot to do is what we need to do really quickly. I'm really sorry. I forgot something. What we want to do is concat file name with .ha. So what we want to do is we want the person to just enter the file name without any extension. Okay, so what we want to do right here, it's not os concat, it's strings concat. Now I recommend you comment your code, because when you come back to this in 2 months, 6 months, a year, and you try and look at it, you know, I'm pretty sure you've written programs and you come back to them and you're like, what on earth was I doing? What did I do here? So I recommend you comment your code every course that I took in college so far, our professors were like sticklers, and they made you literally comment, and I'm literally not joking, every single line of your code. So it's sort of a habit that I got into. I don't comment every line of my code, but I do try and put comments in. So what we want to do now is we want to append .ha onto this file name, okay, onto our file name, so that when we call it with os create, right here, where are we at? When we call it with os create, oops, this needs to go right here. So when we call this with os create, it has the file name appended to it. Okay, and I'm just going to shadow this variable. You see, you can shadow variables in Hare. Be careful with this, but it's helpful sometimes. And now what we want to call is let's match on. What we want to match on is strings concat, because in Hare there's no way to concatenate strings with like the plus sign. Okay, so you see the caller must free the return value, and it can return type no-mem, so this is allocated dynamically. You see it concatenates multiple strings. This is a variable argument, so we can pass in as many strings as we want to. Okay, so let's go ahead and call os concat, or excuse me, strings concat, and what we need to pass in is file name and then another string, and we're going to append .ha to our file name. And we'll say caselet s, str, that's what it returns on success, and yield s, or case no mem, and what I'm going to say is allocation failure. Okay, so now we're appending the .ha extension onto our file name so that when we create it with os create and then later open it in our editor, it already has the .ha extension. And I also need to defer free file name, because this is this is allocated in on the heap, so I have to free it. Now here's where we are going to call exec editor, and we want to pass in editor because that's right here. So we're getting our editor, and again, if it returns void, then it's going to be vi, and then we're passing in the file name, okay, because execcmd operates on a file name, not a file descriptor. So we're passing in file name, editor, and then file name. You see we have that defined here. And now what this is going to do, now I'm going to fill out the error handling later. Okay, so when we create this as a real project, okay, make sure that you fill in all the error handling for this function. But for the time being, I'm just going to leave it, and I will let you fill in the error handling. Okay, so let's step through this. Okay, so we're importing our modules, and I think we need IO. I think we might be using FS. I'm not exactly sure. I think we are. We'll find out. I don't want to import anything that I don't have to. Strings, let me search for it. Okay, so we are importing FS. So let me import that. Okay, use FS. So we're importing FMT, FS, the getopt module, IO, OS, and strings. Okay, so that should be good for now. If I need to import anything else, we'll find out when I try and run the program. So here's the string that we're going to write to whatever file we create. And what we're doing, we're calling getopt parse and defining an f flag and then a parameter that's called file. So this is the rune and this is the string, and this is going to be the file that we create. Okay, and then we're using a for each loop to loop through the ops slice of the command struct. and then switching on the rune values for our flags. And here, and if we have an F flag, okay, we're calling our create file function, which is here, passing in a pointer to CMD, okay, which is here, that now holds this information, right? This is what we want from this CMD struct, okay? And then if it's an invalid flag, we're calling getopt print usage, printing to standard error, our name of our program, and the CMD help, which is all this right here. Okay, this is the CMD help. Okay, it's CMD help. This is the actual field of the struct. Okay, and inside of our create file function, it takes a parameter of a pointer to a getopt command. Right, this way we're not copying, and so it's a little bit better on performance. And what we want is this first the first element of the ops slice, and then the string value, okay? And then we are appending the .ha extension to our file name. We're creating it with oscreate with the proper permissions, 644 in octal format. Okay, make sure you defer IO close, and make sure you defer freeing this file name, because this is appended dynamically. And then we're using fmtf print that writes to an IO handle. And so we're writing our main string that we defined at the top level of our file. We're writing that to whatever file we create. And we're returning it as fd because it's a file descriptor. Okay. Then we're getting our editor environment variable, putting it here. And if it returns void, we're using vi. And then we're calling exec editor, which we've defined here, and passing in our editor and the file name. Now inside editor, you can step through this, right? Inside the CMD, it's os exec CMD. And again, if we look at the top level, it has some instructions for how to use it, and then also exec CMD is what you want. Now what this is, okay, what this is it's exactly similar to exec v and c. Okay, so if you've used exec v in C before, that's what this is. You see, the exec family of functions shall replace the current process image with a new process image. The new image shall be constructed from a regular executable file called the new process image file. There shall be no return from a successful exec, because the calling process image is overlaid by the new process image. And so what that means is this does not return, okay? This does not return. This starts a new process, and we don't need to pass in any environment variables, you see. There's the exec VE, you can give it environment variables. And again, that's what this says here. Possibly using functions like setEnv to customize it. So that would be like if you wanted to call execve, okay, but this is exactly similar to execv in C, right? This is the POSIX Programmer's Manual, right? So this is in C. And so that's what this is exactly similar to. We are creating a new process, and our new process overwrites the current process, okay? So it's being executed in the shell, and it's going to overwrite that with our editor. And so that's what we're doing here. Make sure that you fill in the error handling information. And so I think we're good to run this program right now. Let me define a okay. Okay, a known object. Okay, I was pretty sure I was forgetting some imports. Okay, so I need to import the exec submodule, which is in OS. So we're importing OS, so I want to say use OS exec. Okay, so it built just fine. Let me run it with the help flag, and you see it prints the help message just fine. Now let's try and run it before we make a file. Let's pass in an invalid flag and see if it prints our print usage function. So say Harebrew, and let me pass in Z. You see Harebrew unrecognized option, and so we're printing usage, and it shows you usage here. Harebrew, you can pass in the H flag or the F flag and a file. So now let's make a file. And what are we going to call this? I don't know. Now let's call it hello. Don't put main. If you put in main right now, you're going to overwrite your entire main function because it's going to truncate it. So if you're testing this in the same directory as where you're working, do not put in main. It's going to overwrite your entire file. It's going to truncate it because it already exists. So do not put in main, okay? And you can see it works just fine. It created the file. It appended.ha. It wrote the string contents to the file. So I was correct. We did have to escape this as a sequence, these quotations. It fills it out with some basic scaffolding, and I'm inside of Helix because I have, you see, I have my editor. You should export your editor because a lot of command line programs like FCF, right? If you're, I use LF, and if you were to open a file, right? If you were to open a file, it usually sources your environment variable. So go ahead and export your editor from your shell. Okay. So I'm in Helix right now. Now let's check this. Okay. Let's check this. Let me first of all let me delete this file. And what I'm going to do is I'm going to unset editor, and now let's run this again. Okay, Harebrew file, and let's say hello, and you see it creates it and it opens it in VI. I'm in VI right now. Okay, so you always want to have a fallback on your editor. You could even maybe return Emacs if you wanted. Right, but VI is a good default because almost any Unix system is guaranteed to have VI on it. And so, okay, so let me go ahead and remove this file, and I'll say make clean. And so that is the basics of this project. And in the next video, which I will try and get out as soon as I possibly can, I wanted to get this video out last weekend, but I was waiting on my microphone, and this is like the 4th or 5th time I've recorded this video. It's a long story. It was supposed to come out Saturday. So I apologize for that now that I have my microphone up and running. There might be a few more tweaks I need to do to the audio, but I found that the less filters I put on, the better things really are. So in the next video, what we're going to do is actually build this out into a proper project, so that when we pass in the P flag, we can create a project as well as a license. And we're also going to write out the make file. I'll show you the basics of make files. I'm guessing that'll probably be part 3 because I want to be somewhat comprehensive with everything. So in part 2 of the next video, we're going to refactor this and create a much more structured project, finish the code in order to build a project and add a license. And then I would say in part 3, we're going to build the make file, and I'll step through each line of that. I'll teach you make and the basics of it, and so we'll do the make file, and we'll also make our man page as well. So we're going to be using the scdoc utility on that in order to make our man page. So that should be it for now. I really appreciate all of you watching. I hope you found this helpful. Again, my email is on my project profile on Sourcehut. If you need help, go ahead and send me an email. I'll be happy to help you, or you can put your question in the comments also. So thank you for watching, and until next time, have a nice day.